Now, this is the first session that we having together. We have to rethink the strategies. How are the cities organized to mitigate the effects of climate change? And we have two guests with a cross-cutting approach on the scientific approach. We'd like you to welcome Diane SIMIU, in charge of air and pollution and the MTE, and Mrs. Masson, working at Météo-France. So you have the stand. Good morning, everyone. Thank you very much for inviting me and for this amazing opportunity to present our national policy on adaptation. The first thing we need to say is based on science, and the previous speaker reminded us of the importance of the work we do as researchers, and this national adaptation plan is based on a trajectory, what we call the reference trajectory for wet warming and in global warming. It's based on the commitments of many states, and we based on the hypothesis of an increase by 3 degrees. This being said, Europe is warming up much faster than the rest of the world. So 3 degrees for the world, it implies 4 degrees for France. So we have an increase by 1.7 degrees in France, and we may reach 2 degrees by 2030 and 4 degrees by 2100 if we cannot stop this trajectory and this hypothesis of 3 degrees. Another point that is important is to be ready. You need to get ready to face warming of 4 degrees. It doesn't mean we give up on the Paris Agreement because, well, Mr. Deschutes described this reference strategy, the reference trajectory. We said you're getting ready to have an increase by 4 degrees. Is that you gave up on the Paris Agreement? We don't believe in the Paris Agreement anymore. It's not true. We're still fully committed to sticking to the Paris Agreement. We want to preserve our targets of reducing greenhouse gases. But as the previous speaker said, the geopolitical context forces us to be ready to the situation that potentially the Paris agreements and all the promises will not be fulfilled, and we need to face the potential consequences of this Paris Agreement. And this is why we call it in France the DRAC, DRAC, and it's this reference framework is really the global framework of our actions. Concretely speaking, what does it mean that to live in France with an increase by 4 degrees? So we want to have some analogies and comparisons. So, for example, we wanted to compare cities. For example, the weather, the climate in Paris is similar to the weather in Montpellier, in the south of France. But you may think that's actually a good idea to be as sunny as Montpellier, but unfortunately not, because this temperature increase will be based on an increase of natural events. We have heat waves, may last for more than 2 months. We have forest fires, and potentially half of the forests in France may be potentially victims of fires, and many other events that we can see here, because even today, all the regions are impacted by the consequences of climate change. 11 million houses are built in risky areas. We had widespread appearance of tiger mosquitoes. We are now visible in 78 departments in France, and for 20% of the coastline is at risk to just to give you an idea. Okay, based on this inventory, so we need to have a global approach, what we call a holistic approach. We already mentioned this adjective this morning, because climate change will impact everyone in each and every city. It will have an impact on pretty much all the sectors and each and every individual. So it's important to ask ourselves, for each stakeholder, what are the potential levers we can use? What are the actions we can implement? And the idea is to be able to plan the good implementation of these actions so we can adapt to climate change expected until 2100. So it's not the very first national action plan, it's the third one. How is it different from the previous action plans? We have two main differences. The first one is that the raise of awareness around this action plan. During the last 2 years, I think, and I experienced this because I worked for the Prime Minister while we drafted the second National Adaptation Plan, and I really noticed a change in the behavior of everyone involved. 5 years ago, the National Adaptation Plan was based on the work of the Ministry of the Ecology, and pretty much everyone in the Ministry of the Ecology was interested, but pretty much no one else. But now it's more important because we have more extreme natural disasters and we are much more mobilized, and we can count on the full commitment of all the ministries, all the ministers, all the national bodies. They are much more involved and concerned by what's happening, and so the commitment is quite different, and they feel more responsible in making sure that this national adaptation plan is fully implemented. The second point, the second difference, is the integration of what we call the reference trajectory. We know why we need to be ready, and it will be integrated in the environmental code. It means that will be a complete reference, and the following laws will have to comply with this. When we have to do a vulnerability study, we need to show the consequences of what will be the consequences of an increase by 4 degrees, and it's very important to comply with these rules and requirements in this national plan. So I will not review all the potential measures because the plan was published on the 10th of March 2025, and we have 52 measures with more than 200 actions and distributed around 5 pillars. I'll try just to give you some examples. We need to protect the population, obviously protect the people from extreme heat in their houses, but in the office too. Just a short example, we have a decree which is about to be signed. It will come into force before the beginning of summer. We create an obligation in the labor code to force employers to have prevention measures. And we have to be sure that we need to prevent heat waves, because in 2024 we have 8 deadly events which took place because of heat waves. That maybe more people died, but it was essential to be sure that we can improve the protection of people at work to prevent them from the impacts of heat waves. A second example, to guarantee the good resilience of the provinces and the infrastructure, most notably transport infrastructure and electricity infrastructure, because some cables, for example, are buried in the ground, and they tend to break 8 times as frequently as all the cables. So we need to replace all these cables so we can be more resilient. We can face droughts, heat waves, floods, and RTE, the National Electricity Company, intends to invest 24 billion euros by 2040 in order to improve the electricity infrastructure and replace all these cables. Moving on to the third axis is related to the economic resilience and food sovereignty and economic and energy sovereignty. And everything has to be included in our adaptation plan. So we have requirements, mandatory requirements for companies. They need to provide us with adaptation plan until by the end of 2025, and next year all the most crucial operators it will be mandatory next year. And for smaller companies, we just want to support these companies. So, for example, we have DIAG, what we call adaptation diagnosis. So we can support, thanks to agencies, we can support the smaller companies. We can help them to adapt to climate change. The fourth axis has to do with natural and cultural legacy and heritage. So we have some experiments in various sites, for example, the Mont Saint-Michel in Normandy, so we can adapt the site to climate change. And the last one is how we can count on mobilizing the youth and the workers of the nation. We have a great opportunity to count on the commitment of our citizens so they can participate in this. So we have 6,000 people who responded to our surveys. It was unprecedented, but we see that our citizens want to be committed. They want to have the opportunity to work, to contribute. And this is what we call the citizens' resources, and we'll. So we pretty much like the police, who may have extra people, extra hands helping them. We can actually count on the citizens to help us and to support them, and they can count on the citizens to people involved in the life of the villages. We know when someone's a bit old and they need to know where they can get water, where they can go when during a heat wave. And thanks to these citizens, we can count on their contribution. Moving on to everything what cities can do, and we'll have a discussion on this. What can cities do? They can protect the population against potential natural disasters, for example, floods. And this is why we have the Barnier Fund, and we increased the fund by 30 million euros, so we can have the basins, so we can regulate the flow of the Seine River. You can reduce the risks of floods. The same in the city of Nîmes, we can actually we can move the Miquelon village, and we have other measures based on natural ways. And we noted everything has been done by Paris to plant more trees and more plants. So, for example, we have some specific actions in Bastia, thanks to the Green Fund, to plant trees and to create fresher areas around schools, for example, in Bastia. And the integration of this reference trajectory, which will be included in the most strategic documents in the regions. And to conclude, we'd like to show you an array of services provided by public bodies, and we know that municipalities are on the front line to tackle climate change. And most of the time, they feel powerless because they don't have the necessary resources. They don't know how to start adapting their cities and how to draft a valid adaptation strategy. So the adaptation mission, as presented to the mayors by the Minister Pannier-Runacher, is a list of all what the operators can do: the Météo-France, the DEM, the CEREMA, the OFB, the Agence de l'eau, the ANCT, the Banque de Territoire, with a list of everything they can do to support these territories, provinces, regions, so we can support these regions and we can actually help them to draft their adaptation strategies. So we can have the financial engineering, for example, the Agence de l'eau, the water national authority actually provide more than 1 billion euros in actions to make sure that these regions can start adapting themselves to climate change so we can have a systematic approach.
Pour conclure, vous avez ouvert cette journée en parlant to talk about the adaptation plan to climate change. So this is a national plan, but it was created after a consultation with many stakeholders, with former consultations with the public and with the National Council of Ecological Transition, thanks to the SISU. And it's really a conversation that we must have as a society in a France that will get 4 degrees warmer. What do we have to leave behind and how do we commit for the future? And we can only manage to do that with all stakeholders, from municipalities, from companies, and from citizens as well. Thanks, Diane SIMIU. We will try to keep some time for questions afterwards. We will now have Valéry MASSON, who is Director of Research at the CNRS and CNRM. Hello, everyone. Thank you for taking part in this symposium. So I will talk more specifically about urban overheating. The 6th report of the IPCC showed that cities are hotspots of global warming, and one of the causes is urban overheating and urban heat islands, UHI. So I will talk about the variability of urban microclimate. So it's the difference of temperature between rural areas and various neighborhoods within the cities who can be warmer. So on the right-hand side, this comes from the 6th report of the IPCC, showing that some elements in the city contribute to warm cities up to 2 to 3 degrees annually, in average, but we will see that we can have very variable elements depending on some factors. So heat in cities can vary in time, and it's at its peak at night. There is huge variability between cities. You won't have the same climate within land or on the coast, and this is very important for adaptation strategies. And one big disadvantage is that during heat waves, cities will get warmer because we have an increase of temperature of urban heat islands, and this exacerbates the consequences of heat waves, and we've seen that tragically in 2003, for example. So I will show some former observation on the variability of urban microclimate. So when there is a lot of rain and a lot of wind, rural areas and cities have the same climate. But when wind is low and when it's been bright during the day, we see a huge difference in temperature between cities and the countryside. This is why during heat waves we will have UHI that are very important, and temperatures that can go over 30 degrees quite easily. So UHI depends on the size of cities. The bigger the city is, the bigger the UHIs are. So these are examples of UHIs. They've been measured between the at the beginning of the 20th century, so before a strong global warming. So it is quite independent from global warming, but it's an added extra heat. As I said, it's very much influenced by local geography. So we have, for example, coastal cities that are fresher than inland because we have air coming from the sea, but at night we will have strong urban heat islands even though they are close to the coast. We also have cities in mountains, and they will be depending on winds and where the wind comes. So we cannot define adaptation strategies to heat that are universal for all the cities because we have very different contexts depending on the city we are in. We must really have that in mind. And we have very strong variability within the same city. And it's very important to define adaptation strategies because, for example, where should we put parks? Where are the hottest neighborhoods? And this will lead the action, and we need to see here on the right, we see that we have variability at different scales, so between the city center and rural areas, but also within one city, and depending on neighborhoods, depending on the parks. And on the left, we see here works that are made in China on how to bring fresh air, how to ventilate cities to mitigate pollution as well. So these are also questions that we must consider in urban plans. So this was to explain what are UHIs. How do we observe these data? How do we know that? One big disadvantage we have is that weather observations are not available within cities because official weather stations such as Météo-France, for example, are mostly in airports for their needs and at best in parks. So we see here on the right-hand side at the top, this comes from a specific document on UHIs, and we see here we have one station here in Marseille in a park and one in Paris in Montsouris Park. And other cities don't have an official station. In Paris, we also have a new station from the Poisier Street. It's within a hospital, within the city center, and it's much more representative of the heat we get. We also have weather networks that can be implemented by researchers in urban climatology or by cities or collectivities. So these are professionals setting up stations to be able to analyze the data. Here we have an example in Serbia with a group of urban climatology who are observing that, and we see that the city center is hotter at night, but we see different temperatures in the areas around the cities. And also, recently, crowdsourcing allows to have more observation. For example, individual weather stations. There are over 10,000 in Paris, and we also have connected cars with temperature on the dashboard, and this can help to have a mapping of UHIs. As we can see here in Barcelona, which is a coastal city, we see that during the day we have fresher temperatures in the city in comparison to rural inland areas, but we have UHIs of 8 degrees in August in the city center of Barcelona, for example. I will finish with describing how can we implement this knowledge, how can we use this data. So we must first know the physical phenomena leading to these UHIs. This was said in the former report of the IPCC. So it's city geometry, and to have materials such as concrete or not, storing heat during the day from the sun and giving it back at night. And this creates this temperature difference between rural areas and the city center. And we also have heat from human activity, and this worsens the phenomenon by 1 degree approximately. So these physical phenomena can be included in our modelings in order to create scenarios and to first assess what is there and then to predict adaptation strategies. So we take into account canopies, for example, urban canopies. So we can take into account many physical events and, for example, use the one we see on the right here. This is a day of the 2022 heat wave when we measured temperatures in that period of time, and we see here the two big wood, Boulogne and Vincennes, and we see that it's fresher, and we see also that the Luxembourg Park is fresher. We see these details at this scale, so these are very useful tools in order to see which areas stay fresh at night. And these modelings are used in very precise projection tools. Valéry, you must conclude soon if we want to be able to have questions. So we need very refined data, and we have tools such as local climate zones because it's based on land use. We need other data, and this is when interactions between scientists and cities are very interesting, because cities have a lot of data, allowing to increase knowledge and to help analysis based on these diagnoses. So I wanted to show here an example showing that we need local information. This comes from the Urban Agency of Toulouse. It's a climate atlas based on all the neighborhoods of the Toulouse metropole to quantify the overheating and to see the UHIs when it's low, average, or strong, high. And we see here how important it is to work at very refined local level to see different strategies. So I thank you very much. So just to say, that the World Weather Organization has written 4 guides on urban climate services in order to target urban issues and adaptation strategies. Thank you very much, Valéry. So I know it's difficult what we make you do to present in such a short amount of time. We can take one question if you want, one question here in the room or online. You can also ask your questions. I see them coming in. They are being moderated by Dominique Margutti, that you will see later on, and he does relate them to me. So we can start now here with the room, and if no one wants to ask a question here, then I have some online. There is a question in the room. So you can stand up and briefly say who you are. And please, a short question. Hello, I'm Léo Lenoir, and I work at the municipality of Marseille on adaptation and climate change. We work on overheating in urban areas, and what I want to ask is how can we remodel a city to favor air circulation and implement and create parks, knowing that urban renewal is of 1% per year in average? It's a short question, maybe leading to a long answer, but please, the shortest one. It can be either one of you. Valéry? Indeed, the objective is to inform with scientific facts what we can do in cities, but how can we provide solutions? We can give a general solution, but we cannot give specific solutions to each city because, as I said, each city is different. They all have their overheating characteristics, and it's only through local knowledge that we can implement local solutions. But we need to have this light put on it. But how can we accelerate this transition? This will be mentioned in the next special report on cities that Bart mentioned, that I am one of the author as well, and we will talk about it during the day as well. So I won't give an answer now because many other speakers will mention it later on. This was the Joker card. Thank you. But I also wanted to tease for David Marshall's intervention of the ADEME, who will also talk about the approach called Fresher My City, who supports cities in such challenges. We will also have Elodie Bridge, who will expose this and showcase this project. So thank you very much. And we will continue the conversation during the breaks.